Okay, in the last video here, we're gonna finish this up. 33. We are again dealing with right triangle similarity. I got an altitude, right angle there. I would do x as the geometric mean, but that'd be hard because I'd have 2 over x equals x over y, and I have 2 variables, and that's not going to work. So I should probably find y first. To do that, I'm going to use my 4 over here, but that's a leg of the large triangle, so that's a geometric mean, which is the first time I've done that in these problems, where it's not a variable here, it's a number, but it's still the geometric mean of the adjacent piece and the whole hypotenuse. And the whole hypotenuse here is 2 plus y. So 2 times 2 plus y equals 16. 4 plus 2y equals 16. 2y equals 12. Y equals 6. So now that I have that, now I can find x pretty easily. 2 over x equals x over 6. X squared equals 12. I've showed you on the last video how to break that down. I've shown you many times how to break that down. I'm just going to do this quickly to save some time. That's 2 radical 3. So x equals 2 radical 3. And then I got to do z. So z is the geometric mean, because it's the leg of the large triangle of the adjacent. So 6 and the whole thing. Now I actually have the whole thing here, which is 8. So z squared equals 48, square root, and then I'm going to get 4 radical 3. 34, I'm telling you they're similar. So I want to match up pieces, at least one piece that I have numbers for both. What I mean by that is, well, z, I don't know that, so I can't do a similarity ratio. Y, I don't know that. 10 matches up with x, can't do a similarity ratio, but 5 matches up with 10. So I'm going to use that to get my ratio, which is 1 to 2. Now I'm going to use that to find x, y, and z. We'll start with x. So 1 over 2. 10 is on the smaller, so I'm going to put 10 on top. X is on the larger. X equals 20. Do it again with y. Y is on the smaller, so I'll put that on top. Matches up with 35. So 2y equals 35. Y equals 17 and a half. Z, 1/2. Z is on the smaller. Matches up with 15. 2z equals 15. Z equals 7.5. Number 35. 2 ways of doing this one. You could do side splitter, since I know that these are parallel. Okay? And the way side splitter would work, x over 13 minus x equals 2 over 3. Go ahead and do that real quick. I'll get 3x equals 2 times 13 minus x. So I would get 3x equals 26 minus 2x. Add 2x, I get 5x equals 26. And then 26 divided by 5 is going to be 5.2. Now, I said that you could do it a different way. You could do x over the whole length here. So x over, the whole length would be x plus 13 minus x. So the whole thing is actually going to be 13. Right? X plus 13 minus x, the x's are going to cancel. It's going to be just 13. And then the whole thing, so it's going to be equal to 2 over the whole thing, which is 5, and look what you get. 5x equals 26, same as what you had here. Don't care which way you do it, just showing you that there's multiple ways. 36 is, you're probably thinking the exact same thing. The difference is, it's not side splitter. Yes, I have parallel lines, but side splitter says the parallel line cuts these two sides proportionally. It has nothing to do with the third sides here. I cannot use side splitter because honestly x and 9 were not split. So I have to use 6 over the whole thing. So 6 goes over the whole thing, which is 8, equals 9 over x. Before I move on, I should probably have done this first. Parallel lines mean I have these two angles are equal because of corresponding, and these two angles are equal because of corresponding. And honestly, that equals itself because they're reflexive. But angle similarity is what I have here. Before I could do this, I actually had to set that up first. So, my bad. But anyway, 6x equals 72, divided by 6, x equals 12. Okay. Angle bisector. I look at this and I see that right away. those two things are marked equal. This is angle bisector, which just says 40 over 16 equals x over 15. So 16x equals 600. Just making sure real quick. Yeah, divided by 16, and you're going to get 37.5. 38, again, this one is side splitter. See how both the parallel lines split these sides proportionally. You could also do what I did up here. You could do 12 over the whole thing, x over the whole thing, but this one makes sense just to do side splitter. So 30x equals, I'm going to go ahead and distribute, since you know that's what we're going to be doing, 24x plus 120. Subtract 24x, I'm going to get 6x equals 120. Divide by 6, I'm going to get x equals 20. Last page here. 39. Angle bisector again. Just going to set it up. Y plus 4 over 4 equals 2y plus 5 over 6. So I have 6y plus 4 equals 4 times 2y plus 5. 6y plus 24 equals 8y plus 20. So 4 equals 2y, y equals 2. Okay. Next one looks like side splitter, but again, I have these third sides labeled, so I have to do x over the whole thing. Well, the whole thing is actually already marked, x plus 4. Equals 3 over 5. 5x equals 3x plus 12. 2x equals 12, and x equals 6. Last one here, tricky. I made this one up myself, you can probably tell. It looks nothing like the others. But both of these are 22, which means that's an angle bisector. I also have a right angle down here. A lot of people will look at this one and say, oh, right angle, I'm going to do those shortcuts that we did in lessons 4 and 5. But there's no altitude here. This is an angle bisector. But a right angle here is going to tell me that I can do the Pythagorean theorem. That's 25, that's 7. I can find the last side here, and I'm going to save you the time. 7 squared plus the whole thing squared equals 25 squared. This is going to end up being 24. And that's going to help me set up my angle bisector, because I need an expression right here. So I got 7 over x equals 25 over, but I don't have anything for this yet. Well, if the whole thing's 24, though, and this is x, this is 24 minus x. And now I can solve it. 25x equals 7 times 24 is 168 minus 7x. Distribute, right? Add 7x, I get 32x equals 168. Divide by 32, I get 5.25 for x. All right, moving on to perimeter and similarity ratios, perimeter ratios, and area ratios. Last lesson, which I know was right before Thanksgiving, a lot of you probably didn't get this as well as you probably should have, so try to get it here. Okay? Two similar diamonds have areas of 75 and 27. Right away, I see that I've given you two areas. That's an area ratio. So I'm just going to go ahead and write it out. And I'm going to label it area ratio. Okay? If one side of the smaller diamond is 12 centimeters, what is the length of the corresponding side of the larger diamond? We'll come back to all that. What we have to do is we have to get this to a similarity ratio. To do that, I need to do the square root of both top and bottom. But the square root of 75 is not nice, so it's probably a good idea to reduce it, if you can. I see that I can take 3 out of both of these. And when you do that, look what you get. You get 25 over 9. Still an area ratio. Reducing does nothing. Now, though, the square root is much nicer. Square root of 25 is 5. The square root of 9 is 3. There's my similarity ratio. This is what I use to set up my proportion. I said the side of the smaller diamond, smaller is the 3, is 12. So it's going to go on the bottom. what is the length of the corresponding side of the larger? 3x equals 60, x equals 20 centimeters. 43, in two similar hexagons. Okay, the similar is important. One with side length 4 feet, and the other with a corresponding side length of 18 feet. The area of the larger is 648. What is the area of the smaller? So what I've given you here is 4 to 18. That is a similarity ratio. I'm comparing one side. Okay? But I can reduce that again. That's 2 over 9. And that's a similarity ratio. They both are. This one's just reduced. To get to an area ratio, I have to square both of them. So 2 squared is 4. 9 squared is 81. That's what I'm using to find an area. If I'm looking for an area, I have to use an area ratio. If I'm looking for a side, I have to use a similarity ratio. Which is basically going backwards here. So 4 over 81 equals, the larger hexagon is 648. Smaller. So 81x equals whatever 648 times 4 is. 2592. Divide that by 81. 32. So it's 32 feet squared. It's an area, so feet squared. 44. 6, and I'm looking for x. So I'm looking for a side. What I need is a similarity ratio. What I was given were two areas. I've given an area ratio. But I need to reduce it. I can divide by 5, which is going to give me 16 over 49. Still an area ratio, but now it's reduced. To get it to a similarity ratio, I need to take the square root. To go down to a similarity ratio, we get 4 over 7. That's what I'm using now to figure out x. 6 is on the smaller, so it's going to go on top. X is on the larger. So 4x equals 42. 42 divided by 4, I believe, is 10.5. And that's the side, the corresponding side. Okay. 45. Gave you the perimeters here. Now, I haven't talked about perimeters yet, but perimeters and similarity ratios are the same. So this is the same as a similarity ratio. 72 over 48 is a perimeter ratio, which is also a similarity ratio. They're the same. You can still reduce this. I know well, you can take out 24. Yeah. It actually reduces all the way down to 3 over 2. I'm looking for the area of the larger. I've given you the area of the smaller is 34. So what I have to do is square both. So I get 9 over 4, and that's what I want to use. So 9 over 4 equals, 34 is the smaller, putting it here. 9 times 34, 306, divided by 4, 76.5 inches squared. Okay. Oh, over here I should have labeled that meters. It was meters squared for the area, so this one side is just meters. Okay, last one. The areas of two similar decagons. Don't care what the shape is. They're similar. That's all that matters. 160 and 242. So 160 over 242. What is the ratio of their perimeters? What is the ratio of their sides? Reduce this. I can divide by 2. It's going to give me 80. It's 242 divided by 2. 121. Okay. I can't reduce that any further. Square root now. Right? Because that's still an area ratio. To get to a perimeter ratio, I need to take the square root. So the square root of 80, not a good number. It's 4 radical 5. So the square root of 121 is 11. So that's as far as I can go. So it's 4 radical 5 over 11. The ratio of their sides is the same as the ratio of their perimeters. So those are the same. And we're done. Hopefully that helped you get ready for the test tomorrow. Yeah, good luck.